So now the first one is so my name is Adam Bean or Bien or whatever. I don't care. Bean is a fun because there's a Mr. Bean, and I got some confusions already. You know, on the gas station, people say, "Ah, you are the Mr. Bean." Saying, no, just a Bean. And also, what I did back then, I think was 1997. No, later, 1998, 9. I delivered some EJB courses for Java Beans and EJB courses for Sun Microsystems. I was a freelance trainer from time to time. And if I introduce myself, my name is Adam Bean, and welcome to the Java Beans course, right? And no one could believe that my name is Bean because it, matches the Java Bean and Enterprise Java Beans, which was fun. So today is a little bit harder. So a better name would be Adam Lambda or something like this, but it's really hard to rename myself, I would say. Yeah. So you saw already the podcast. There is an AirHacks Live, which are workshops. The plan was to deliver them 4 times a year. The problem is I spend too much time in projects. So this year, I think there are only 2 times a year. So the next one is in December. So if you like to join, there are 2 AWS related workshops. It's related to this topic. One is more about debugging, monitoring, observability, infrastructure as code in Java. And the next one is going to not to be hardcore Java, a hardcore serverless Java, more or less like, Fargate, a little bit Lambda. And I plan next year going more hardcore. What do you cover this, like a preview? Both in December, and then maybe the next one I think is going to be April, May or something like this. And because I'm already in projects until March, and what I plan to do is one maybe migrations from micro profile Java EE to the cloud, and the other one infrastructure as code. Okay. So AirHacks TV, this is a useful slide. If you have any questions left, go to AirHacks TV, where you will find a link to my GitHub gist account, and you can just ask a question, whatever you like. And I answer all the questions at the first Monday of the month. Always the first Monday of the month at 8 p.m. And there's already a 93rd edition. So I do this for, can it be 5 years, 7 years, something like this? So it is an old show. Okay, now what I promised you today, and why this crazy topic. First, it's fun. Second, can be very interactive, and this is well suited for Devflix. And I did EJBs a lot actually, and Java EE and microprofile, and I still like them. I have to admit. For me, EJBs, they're just lightweight, and this is and they are just working. They are also fast. And what I found, that they are almost identical to AWS Lambda. And this is what the topic is about. So if you know EJBs, you would immediately understand Lambda. And if you don't know EJBs, hopefully you will learn how they are working behind the scenes during this hour or 2 hours. Okay, so let's cover this. So we have the lifecycle of EJB. So what EJBs are? I would like to cover only 2 types of EJBs. Message-driven and stateless EJBs, and compare them to synchronous and asynchronous Lambdas. So what was the idea? So back then, maybe the Gregor remembers, or all the Java developers remember, hardware was very expensive. And so in the year 2000, most of the servers I used in companies were roughly, started from, I would say, 30,000 euros was the smaller one, and the million was the E10K. And Kasper asked me, will be available as recording. I'm not recording anything. I hope Gregor records something. And but this is fun, so we don't have to record that. And like the Sunfire machine, which was based on Cray, it was roughly 1 million. And so I was in a project where we had 2 such machines in a cluster, and we shipped application server to the cluster. And the whole idea of the application servers was to save money, or to distribute the costs of the hardware of the 1 million to several projects. This was the idea. And and EJBs were like the application model. And if you think about this, it was actually serverless. Why? Because the server was somewhere, no one knew where, in a data center. And what you shipped an ear back then, and you didn't even knew how much CPU the server had, how much RAM the server had, it just ran. So if you think about this is exactly the definition of serverless. And almost, right? Because there were no costs, basically, and you have pay right now, but you get roughly the idea. So we had a packaging format. This was EAR, which I didn't like. WAR was better, but back then EAR. And this EAR comprised WARs and EJB jars. Everything was zipped and uploaded to the server. The server unzipped that and and installed everything. Now, the first 5 minutes are almost over. So, okay, the first question doesn't count. Will be available. The recording is available. So I think now will be time, for Gregor to ask a question. So now the EAR was deployed to the server. The server unpacked the EAR, and we get the EJBs. Now the lifecycle is. Now the problem back then was Java was relatively slow. In the 1 million machine, I think was less powerful than Raspberry Pi. So what we had to do, or the entire idea of stateless EJBs was to have pooling. So and JSF and WARs back then. Maiko, very good. JSF was not available yet back then in the dark ages. JSPs and servlets. So we had EJBs was in the jar, and the formal name was EJB jar, and the WAR were JSPs and servlets with great servlets frameworks like Struts. And by the way, Gregor has to invite this guy. I had a great conversation with Struts committer, a Polish guy. Wait a sec, a really nice guy, and you have to wait a sec. Where is it? I forgot his name. Not Mohammed. This Lucas Leonard. This is his Twitter handle. A great guy, and this is the main committer of Struts 2, and he lives in Poland right now. And we had that conversation actually this year. So the job of Gregor is to invite this guy, and he can deliver, the entire history of Struts 1 and Struts 2, and also very interesting, the security hack where the half of US where the data was stolen, it was actually stolen from Struts framework, and this is the guy working for Software Mill. So this is the home assignment now for Gregor. So okay, long story short. What we needed to have is pre-initialization, because new was slow in Java. So what we had the problem of cold start. If you invoke new, it could take, 100 milliseconds was too slow, and this destruction was also slow. So what the application server did, it pulled the EJBs. There were stateless EJBs without a state. They were pulled, and if you wanted to have an EJB, it was taken from the pool, assigned to you, and you can use the Java code. So what you had the EJB container, you had a proxy and the EJB, and forgot about the remoting. Even if the bean was local, this is how it worked back then. So, and you can set up the pool. For instance, what I did before the show, I prepared really well. So this was from the Glassfish 3.1. This was already a late edition of the Glassfish. So this was max pool size setting, and there was initial pool size. So what you could do is you could say, I would like to have, the init size of the pool like 1. So on the startup of the application server, the first bean was initialized. If you did nothing, the max pool size were 64. So you got 64 instances of Java objects waiting for you. So later, Java became better, and later means JDK 1.4, 1.5, or 5, 6, 7, 8, and so forth. I'm speaking now about JDK 1.1 and 1.2. So this was a different world. And but the interesting story is, even right now, stateless EJBs are faster than CDI request scoped. Why? Because the entire object graph has to be injected only once and is not re-injected all over again. So Corkus fixed the problem because it eliminated reflection. But if you have a non-reflection-based application server, you will still see the difference. Okay, so what it means is EJBs work this way. The first invocation was slower. All subsequent invocations were faster. So, but what is also true in stateless EJBs is the following. You could only have one transaction or one thread, one request in one instance. If you had the second request, what happened then is a new instance of EJB was started. You have one thread, one instance. So what meant is, if you monitored EJBs and you saw 3 active instances, you knew we have 3 parallel transactions going on. By the way, Lambda is identical. So we can replace EJBs with Lambda and you will know how Lambda operates. There are subtle differences, but it is very, very similar. Okay, so you got the idea? So lifecycle means EJB was created with a constructor, then the dependencies were injected, then post-construct was called, and then the EJBs was in ready state. So bulkheads pattern came later. This was, the whole hysteria of microservices. Oh, that's a question. Okay. So Christoph will also but I see a recording button glowing. So I think the session is recorded. Gregor, is it recorded?
Yeah, I'll join. Yes, I'm recording it. We'll publish it, but not just after the session, probably in a couple of weeks, just to make sure that people are here, and because this is the interactive session. So we are recording it and we'll publish it, but probably in a couple of weeks from now. Yeah.
So you have, transfer some money to Gregor, a credit card, and then you get the recording, right, Gregor?
No.
Okay, cool. But still, this is the boring museum technology where I'm talking about EJBs, but it's really crazy how similar both technologies are. And, EJBs is this old technology and should be a legacy. And I was told, 15 years ago that EJBs are dead, and I remember that. So now I know Lambda, so which is actually I was lucky. So bulkhead pattern came with the entire microservices hysteria. So there was a book released, and in this book the bulkhead pattern was mentioned the very first time. And what bulkheads are? Relatively simple. You could say I have 10 EJBs in my application servers, and every EJBs would like only to have 5 concurrent instances, right? So 5 instances. Why? Because you exactly know the server is only allowed to have, or is only robust enough for, let's say, 100 threads. So what you would like to have is, to spread or to distribute the concurrency of 100 to 20 beans, and each bean has 5 threads, right? Now, Lambda, identical. The only difference is, if you do nothing, it depends on the region, but in Frankfurt, you get 1,000 concurrent executions, and you can do the same with Lambda. It is called reserved concurrency, not a pool, but it's exactly the same behavior. So you can say, I would like to dedicate to this Lambda no more than 10 concurrent invocations, right? So it's built in bulkheads, exactly the same principle. So if you know pooling in EJBs, now you know the reserved concurrency, which is different to provision concurrency, but reserved concurrency we covered right now. So, there's another pattern in Lambda, because Lambda scales, I think between 500 and 1,000 threads per minute up. And what you could do, if you have several thousand Lambdas, you can destroy your database, because not every database is custom to work with 1,000 concurrent connections. So with the reserved concurrency, you could actually protect your backend resources. The same was true for EJBs. I was in task forces. What happened then? There was a JDBC connection pool with 5 connections, and EJB, there was no max pool size. So what happened then is there was more concurrency in EJB level than a database can actually handle. And then we got timeouts, sometimes, out of memory errors, because every thread takes some memory. And I'm using the same problem as like in Lambda, and exactly the same principle. Okay. So, and please ask, you can also, you are very welcome to ask other questions than whether this meeting is going to be recorded, because, take the time, it should be interactive. And Gregor, do you have at least first question, because your audience only would like to have the recordings, but they don't care about anything else. Gregor, your first question. Gregor is sleeping. He's back. An intelligent question, please, Gregor. You are muted.
Sorry.
No.
So it's hard to think about a question right now because we are explaining very well. So.
And you had to use EJBs or not back then?
At the very early stage of my career, yeah.
Yeah, but interesting part is I was hired, to fix the problems with EJBs, and what the cool story is, or cool fact, EJB. I never had a problem with the scalability of EJBs. The problem was always backend resources, database logs or host logs or IOs. But EJB scaled extremely well. This is actually the interesting part of but everyone suspected EJBs to be the problem. So yeah. Now it doesn't matter anymore because we have CDI and other technologies, but it's still interesting, to know. Okay, so okay, Gregor, if you don't have any questions, so in the next 5 minutes, or you have to animate your audience to ask questions. Ah, very good.
Yes, we have.
We like old technology, like old car which still run even better than a newer car. Very good. I'm with you, Miko, because the newer car, there's lots of cheap computers inside, and it's not about quality, and this is why they cannot be delivered, because the chips they are built in modern cars are from 1945. This is this is the problem, right? So Miko, Miko is very active, very good. So now we cover the bulkheads. Now the state. This is important. EJBs was told to be stateless, which was not true. EJBs didn't have a client-specific state. So what if you injected a JDBC connection pool? If you think about this, this is the state of the EJB. If you fetched, some constants or configuration and loaded from XML configuration or let's say zip codes which were static, so this was a state of a stateless EJB, but the state was identical to all clients. The same is true for AWS Lambda. If you read the spec, they even encourage you to read the spec at the beginning of the to read the state at the beginning of the Lambda's lifecycle from the local folder, from a local directory. And they say use static initializers to improve the startup performance. So if you have, if you like to preload something, do it in static initializers. And in EJBs, there was a method post-construct. In Lambda, you can do something in constructor or in static initializers. Why this? Because in Lambda, there is no dependency injection. So Ivan asked me or says, I'm currently using EJB in my projects. Works great. My customers have a great experience in their apps. Very good. So perfect. So, but if they, sometimes this is about fashion. You say, EJB is old. We have, to go public cloud or whatever. So then you say, okay, I know EJBs. I'm going to be AWS Lambda expert. And the serverless Lambda is the new hotness. So Ivan, just do you prefer? What it means, Ivan? You are EJB expert, and it's very easy to you after this 1 hour session to go to the cloud, if you like. If no, stick with the application server. Ivan, question to you. Which server are you using? Payara, Whitefly, OpenLiberty, Tommy? Would be just interesting. So if WebLogic or WebSphere, maybe not. Yeah. Payara, very good. So most of the Payara people are actually happy with Payara. Okay, we covered state. Now the optimization patterns. So what we optimized back then is the initialization. In post construct we pre-initialized everything. Then with the cold start. So the first invocation was slow. All subsequent were fast, which is identical to Lambda. Now interesting. Synchronized and static in EJBs. Synchronized didn't make any sense. I saw in lots of stateless EJBs project, lots of synchronized. It doesn't make any sense. Why not? Because I told you already. It is mission impossible to have 2 threads in one stateless EJBs because you always get 1 instance per thread. The same is true for Lambda. If you're coding Lambda with Java, synchronize doesn't make any sense because every thread you get a new instance of the Java class. Not only that, you get a new instance of the entire container behind the scenes. So synchronized doesn't make any sense in both cases. The first difference between EJBs and Lambda is static. It means something different. So on EJBs, static means you can have multiple EJB instances and all see the same static instance. On Lambda, this is impossible because not everything is running in one JVM. In Lambda, it would be like if every EJB would run its own cluster. This would be the behavior, right? In EJBs, you have 2 cluster nodes, and the static is only visible inside a cluster node because one cluster node is one JVM instance. And on Lambda means every Lambda is a cluster instance. Why this? Because every Lambda gets executed in a Docker container. So from the lifecycle perspective, Lambda gets started, initialized, and stopped. And like the pooling on application server keeps, the beans are kept warm by the EJB container. And in Lambda case, the Docker containers are kept warm by the Lambda runtime. Exactly the same principle. So now, but the static still works on Lambda, but differently. So what Lambda does, it freezes whatever is static for the next execution, and then it just restores that, right? But the static is like optimization. And Lambda packages everything like a zip. So it's very similar to EAR. So you can use Maven Shade plugin. You just put all the dependencies you have to a zip, and then you have the Lambda packaging. Very good. So thank you for all the EJB people. So I also like EJBs, no problem at all. And CDI or EJB is just different annotations for me. At stateless or request scoped, I don't care. Actually, EJBs are even leaner because you only have to put at stateless. With CDIs, you will have to put request scoped and transactional, which are 2 annotations, right? So, and Lambda, there are no annotations, or even leaner. It's just a POJO. So if you like, I can deploy both and Lambda and show you how it looks in real life. So I don't have to talk the entire time. I could also code, but this is, I think, the principles are easier to grasp on slide. Now, this is a beautiful diagram stolen from the EJB32 spec from 2011, I think. So this is older spec. And you see, it's always the same. There's a proxy. And the client calls the proxy, which is always available, and the proxy tries, to get an instance of the bean from the pool. Lambda, exactly the same. You can always call the Lambda synchronously or asynchronously, and you run a Lambda runtime, which is very comparable to EJB container, will try to find a warm execution environment, and if there is nothing warm, it will perform a cold start, identical to application servers. Okay, now stateless EJB lifecycle. So the bean doesn't exist, so it gets instantiated with new constructor, dependency injection, post construct. Lambda, you will see in a second, very similar, except not only the bean has to be instantiated rather than the Docker container. So what we will see before in Lambda, the code is downloaded, Docker container started, bean instantiated, static initialized, performed, constructor invoked, and then the handle method. And then method in Lambda, Lingo. By the way, I'm talking about AWS Lambda. The same applies for Azure functions. It doesn't have to be, but Amazon was the first with the AWS Lambda concept. This is why I'm talking about AWS Lambda. Azure functions is identical principle. Or Oracle functions. And by the way, if you like to play with Lambda at home, or there is an interesting project, FN project, exactly. This is a project, open source project from Oracle, and you can have a Lambda-like environment in your own Docker containers. You can play with it. I also recorded a few years ago some videos on my YouTube channel. Okay, nice. So what have we? We have the life cycle of the EJB, and if the EJB was no more needed, some containers you could specify, like the max, how to call it, high watermark and middle watermark, and they say, okay, at peaks create 1,000 instances and then go back to 30. So then the EJBs were destroyed and were indeed does not exist. The same is true for Lambda. If you invoke Lambdas frequently, they always are warm. If you're not invoking the Lambdas in one point of time, no one knows when. It depends on internal algorithms. But in one point of time, the Lambda gets how to call it, killed or ripped off or whatever. So it is removed. Okay. Now for message-driven beans. And now I would just cover today stateless and message-driven beans. So message-driven beans from the lifecycle perspective, identical to stateless EJBs. But if you know stateless EJBs, they are very similar to or identical from the principle to AWS Lambda with an API gateway. So what you can do, you can pick your microprofile application, package it as a Corkus app, and ship it to the cloud. If you like to see it, say something to chat, and I will do it for you. And then you can call your JAX-RS endpoint as a Lambda. Why you would like to do it? Mostly to save costs. So the alternative is to run ECS Fargate or Kubernetes or EC2 machines. But with Lambda, you get the first 1 million gigabyte seconds or invocations for free. And then you have to pay something. For Kubernetes, you will have to pay at least 80 to 100 euros a month just for the control plane. On the cheapest EC2 machine is roughly, I would say, 30 euros a month, something like this. And Lambdas is the cheapest possible solution. So you can actually package an old Payara application as a Lambda and execute it if it's stateless, of course. Okay, Gregor, your audience is not very interactive, I have to say. The Miko and Ivan, they need a small gift or whatever, but all the others are sleeping actually and waiting for the recordings. This is my impression. So go ahead. So we have the message-driven beans, and as you can already see, there were multiple message-driven beans, and the interesting part, you see here destination or endpoint, and this is identical to Lambda. What Lambda does, it also speaks about endpoints, because the message-driven beans, you could map message-driven beans to GMS or JCA connector. And there were already examples. You could, receive with message-driven beans emails, or you could do whatever JCA or listen to SAP events or whatever. So message-driven beans were not bound or related to GMS. The same is true for Lambda. AWS Lambda listens to everything. So there are event sources for S3, SNS, SQS, Kinesis, HTTP, Kafka, API gateway, REST API gateway, event bridge, and whatever. So there, the entire cloud emits events, and you can listen to the events with Lambda. Even the CI/CD pipelines are emitting events. So this principle very similar. Okay, Jean Michael says he would like to see it. So you will see in a second. So message-driven beans. Exactly the same, the same life cycle, and this is already very, very similar to Lambda, except in Lambda there is no post construct, but we will get something similar in Lambda. And Lambda doesn't have dependency injection out of the box, except you are using Corkus, but this is AWS Lambda doesn't know anything about Corkus. By the way, if you would like to run, cloud native stuff in the cloud, they are the best frameworks to my knowledge. Best means you will save the most costs with them is Micronaut or Corkus. I personally prefer Corkus a bit because it, whatever whatever talks I showed you in the last 10 years at Devox, Poland, Krakow, it was EJBs, microservices, microprofile. So all the source code is still compatible with Corkus, which is great. Exactly. And the message-driven bean EJB had one method on message, and a Lambda has one method, whatever you like to call the method, and the input is always JSON. So this is the AWS Lambda. Okay, now I also do code reviews. End of year, right now, even 3 concurrent code reviews for different companies. And back then, everyone cursed about EJBs because of the programming restrictions. And I saw lots of hacks, like people hated EJBs because of the programming restrictions. And what they did, they coded everything in servlets because there were no restrictions, which is crazy. Because the servlets and EJBs, they run in the same JVM. So, but if you read, I just accept from the spec. If you read this, all the restrictions are just reasonable. And if you know the restriction of EJBs and apply them to AWS Lambda, your Lambda will run better. Let's see. So what you see here, an enterprise bean must not use read, write, and static fields because it doesn't make any sense and is dangerous because of concurrency. Lambda, very similar. You can use static fields as optimization at startup time, but I would not rely on static because, as already said, it works differently. There's one JVM per Lambda. You cannot share, via static, the state between 2 Lambda functions. Mission impossible. An enterprise bean must not use thread synchronization primitives because it doesn't make any sense. It also doesn't make any sense in Lambda. But this is a little bit different. What you can use in Lambda, but shouldn't do this in EJBs, you could actually start threads in Lambda. No one prevents you. So you could actually use executor service and have parallel execution, which is fine on a Lambda, but is not that. It's a completely different story in EJBs, interestingly, because all EJBs would run in one JVM, and one Lambda runs in one JVM. It means if we get 1,000 Lambdas, we get 1,000 independent JVMs. So it's perfectly fine to run multiple threads in a Lambda. So this is a little bit different. But this is unusual, I would say. This is only for very, very specific cases. An enterprise bean should exercise caution when using the Java I/O package. Lambda the same. So there is only one folder where you can read and write. It's called temp. You get, I think this is you get small amount of storage. As I remember, 5 gig or something like this. And the storage is ephemeral. It means if the Lambda disappears, the storage is gone. And this was the reason also in EJBs, because back then we had clusters. If you write to one cluster node, this data is not available in other cluster node. Lambda is even worse because you have several hundred containers. So it is very unlikely that you can share data between the containers. So one difference, Lambda comes with built-in functionality to share files, and this is called EFS, Elastic File System. So you can actually mount, it is actually NFS. You can mount directories and then you can, communicate, but this is very unusual. Okay, but this is a legal way, Enterprise bean must not attempt to listen on a socket, or implement a socket server, even worse, which is, in Lambda is also problematic. But in Lambda, you could use SDK, AWS SDK, to talk to backend services. But what is best practice on AWS Lambda in this particular case is to use keep alive to minimize cold start. So reflection APIs, it was prohibited for EJBs. Only Lambda is also prohibited. It is too slow. So this is why Corkus and Micronaut, they eliminated the entire reflection to have faster startup times. And if you would reintroduce reflection, you will ruin, the experience or the performance. So now, why I'm so about now performance? So years long, I talked at conferences and said, who cares about performance? Is good enough. So now, the first time in the history, if we switch to Lambda, you will see at the end of the month that faster code is cheaper than slower code. So the first time in the history, time is money. And therefore, we should optimize for that. And interestingly enough, Java is faster than TypeScript, JavaScript, or Python. So if you keep using Java on AWS Lambda, you will save money. And you can actually present this to your managers that Java is faster, and which is actually great. So we can save money with Java once again. Okay, now class loaders creation in Lambda is also strange. So you shouldn't do this. Socket factory, server socket, also bad idea in Lambda. An enterprise piece must not attempt to manage threads. Okay, in Lambda, there are corner cases where it makes sense, and usually don't do this. And this is just except from the programming restrictions. Just search for programming restrictions in the spec, and I forgot but this is the same reference. Everything is from there. So now, we're done with EJBs, and now we will map to what we learned with EJBs to Lambdas, and you will see is identical. Or from my perspective, is identical. If you find something which is completely different, or you say, the talk is strange, it's completely different for me, just feel free and comment, write a comment to the chat, or you can even activate your mic or camera, Gregor told me, so we can have a fully interactive experience, which would be actually nice. Greg, do you have any questions? Greg will have to connect again, wake up, drink some coffee, unmute.
Yeah, it takes time. Probably I should hide myself. So why should we have Lambda if EJB is working as good? Why people are moving?
Very good. Yeah. The question is why we should have clouds. That is the interesting part. And because, very good question, Gregor. Actually, excellent question. So why to go to public cloud? If Ivan was happy with EJB, I was happy. So what happened to me in the last 2 years several times on my clients. So in one project, we were very happy with OpenShift and Whitefly. With EJB CDI, everything worked fine. We used the open source version of OpenShift. My client was happy, developers were happy, everyone was fine. And the problem was, it was a crucial project, and we were asked for catastrophic HA, high availability, which meant we would have to install another OpenShift cluster with some kilometers between the distance, and this was not possible first. And cloud is this very usual way to do this. So you have two availability zones, and this is the recover, right? So this was the first problem. The next problem is clouds are most secure in most data centers. So we have specific in German how it's called, certifications. And if you look at the data centers of most of larger companies, they are not as secure as cloud. And if you go to a public cloud, you can secure data at rest and in transit. So from the political perspective, I mean, from the papers, you are more secure, and this is what is demanded. So you can have very easy certificate rotation. So what it means is sometimes you are forced to go to public cloud. And if you go to the public cloud and you would run application server in the public cloud, you don't get any benefits. And what you have to know is that public clouds are always more expensive than in-house data centers, except there's a crazy, internal invoicing. But, a local machine is always cheaper than the cloud. So what means is, if we go to the cloud, we have to save costs, and we will need a benefit, something which, makes the management happy. And if we just pick, internal Kubernetes and push it to the cloud, this is like refactoring, 5 years ago. The application is offline for 5 months, and afterwards it will behave exactly the same as before, hopefully. And but the developers are happier, and the clients not always. And so if you go to the cloud, I would say there has to be a measurable benefit. Either the costs are lower, which probably won't happen, or at least the application behaves better, is safer, or whatever. So, and therefore, Lambda is interesting because with Lambda, you get that. And this is the next slide. So this was an excellent question, actually. And also, if you think about EJBs, if your server ran on premise, you had a cluster of 2, 3, 4. You are 3 JVMs, right, or 4 JVMs. So in the cloud, you always have let's say your JVM in one data center is called AZ. For instance, in Frankfurt, there are 3 availability zones. So you would get 3 subnets with 3 JVMs, and there will be the EJBs inside, and we would need something which runs 24/7, and it will create costs 24/7 all the time. Okay, so for you, if you have a smaller application, it could make sense, but Kubernetes is probably too expensive, and other like Fargate makes more sense. Fargate on Spot even more sense. Yeah. Very good. Are you happy with the answer, Gregor?
Yes, I am. And there is one more question from the Jean-Michel or Michel. I don't know how to pronounce the name.
Jean-Michel Jarre is her last name.
Yeah.
You know Jean-Michel Jarre, Greg?
Yeah. I know him.
Magnetic fields. So, is there any downside to Java Lambdas compared to JavaScript TS Lambdas, for instance, cold start? Yeah. No. I'll show you in a second. I wanted to do it right now. I do it right now, maybe. So what I would like to do is, I would like to show you something. I prepared, so on my GitHub account, I published 4 days ago AWS Corkus Lambda CDK plane. This is what I would like to use right now. What this is, it is a microprofile application with injection, which runs as AWS Lambda, ready to use, completely with Java, no YAML. And I would like to use it right now. So this is, remember, AWS Corkus Lambda CDK plane. You can clone it and you can have it. So, and on YouTube, there are a screencast, which I did everything. So this is recorded. Now, set up Corkus. Corkus Lambda with CDK AWS project. What happens behind the scenes in clones the repository. And I would like to create a repository called Devflix, of course. A project. If I do this, I get 2 projects. Let's do it this way. Hopefully it will work. So this is my application. If you take a look, this is regular microprofile application. It looks like Java EE or microprofile. So it comes with REST easy and something unusual, Amazon Lambda REST, which behind the scenes it creates the packaging, but this is stock Corkus extension. And if you take a look at the source code, it looks like Payara or Glassfish. No difference, like Java 6. And greeter is the business logic. They are just implementing no microprofile injection just to make it a little bit more realistic. And you see, we have injection twice. So this is, I would say, a fat Lambda, a sophisticated Lambda already with dependency injection inside. Okay, I could run it locally with Maven Corkus Dev, but I don't like it to run locally because I would like to ship it to the cloud. And what I did, I used the official CDK from AWS called a Cloud Development Kit, and this is Java. So I say I have a project Devflix, there are the tags, and this is my stack. And the stack says I would like to have 512 megs of RAM. I will tell you why that much in a second. Max concurrency 2, this is like max pool size just for fun. I don't need it. I just wanted to configure that, and the timeout was 10 seconds. And what I'm doing here, this is the entire configuration for Lambda function. It says I would like to have Java 11. In 2 weeks, there's the reInvent AWS conference. I hope we get Java 17, but right now it's Corretto 11. And this is the deployment unit. Handler is the function handler. You see, this is one handler from Corkus, handle request, and I will explain in a second why this. And this is basically it. So what I would like to do is I would just rename the Lambda because it is not greetings. I call it Airhacks Devflix. Devflix. Okay. And now hopefully we can run it. So this project ships with shell scripts to build it, but they are trivial. I'll show in a second. So this runs, builds the Maven, runs the unit tests, which creates CloudFormation behind the scenes, and then deploys the CloudFormation. As I said, this is AWS technology, comes not from me. There are 0 external dependencies. Everything is from AWS, which makes sense because we are shipping to AWS cloud. And this script is trivial. What it just does, it says clean package, CDK, cloud development kit, deploy, everything, and don't ask me, just do it. Because otherwise it will ask, may I create this IAM policy? And this is... can you compare this solution to IntelliJ AWS SAM? Yeah. SAM is a part of the solution. So what Corkus does, it creates already the SAM template, so I could use it right away, SAM. The cool story here is, and so this is a little plug of Airhacks Live. We'll do it in the next workshop. The cool story is, because this is Maven, I can create my own construct. So this example is trivial, but what we do in projects, we create a VPC with security groups and Fargate cluster and endpoints. Now, the construct is jar, so we can put it to Maven Nexus and reuse it inside a team. And because if you think about this, this goes a little bit too far, but if you think about this, all EVPCs are identical. The only difference is the name or some tags. So with that, I can reuse and make the development faster. That's the reason. For instance, what I always need for my clients, a VPC with VPN. So I have construct, VPN construct is reusable. So I launch it and and can save time. And with SAM, it's harder. So I will have to submit the application to a registry, and my enterprise projects is not always allowed to do this and stuff like this. Yeah. And IntelliJ is nice, but Visual Studio Code is going strong. There's a very good support for Lambdas already from AWS official support. Yeah. And it's free. Caspar, I hope you are happy with the answer. So I drink some water and hope that it is deployed. Let's see. It is. So this is my Lambda. This is the URI. And what I would like to do is to go to the browser, but I need the other browser, the Chrome here. And here is my Devflix. Was deployed 1 minute ago. So, and yeah, let's see. So this is the API gateway, the Devflix Lambda, and we could test the Lambda here. Let's do it here because you will see the cold startup time and the behavior. So, so let's do it from here. So I would like to have the REST or RP proxy, and it creates this. So what I would like to do is to say hello, and I need a method called get, and say test. So this is the cold startup time, and if you take a look, so it took 3.5 seconds and initial load, and you get built for 1 second. This is the cold startup time, and we have 512 megs of RAM, and this is the Corkus response, and hello Corkus as AWS Lambda. Now, if I do it again, this is the interesting part. Test it. Now you saw there was no more cold start. It was 9 milliseconds. And now every subsequent call should be faster than Python or JavaScript or a TypeScript. So now we are saving money, 6 milliseconds. So why I used 512 megs of RAM? As you can see, I only used 163 megs of RAM. It's because the Lambda RAM, this is different to EJBs. The more RAM you dedicate to your Lambda function, the more CPU power you get. And if you run with 128 megs of RAM or 256 megs of RAM, usually it is more expensive than 1 gig setup. Why? Because with 1.5 gig RAM, you get 1 virtual CPU. And what can happen is that your code will execute faster with 1 virtual CPU, and you will save money. So this is why I always get, I always dedicate 512 megs of RAM or more, and not even think about dedicating 256 megs of RAM, because 128 megs of RAM is equal to 1/13 of a CPU, which is crazy, to ship something which runs on 1/10 of a virtual CPU. I'm not crazy, but it does make a lot of sense, I would say, performance-wise. Okay, cool. You see how fast Java is. So we deployed the entire Corkus app on Corretto, not GraalVM. This is stock JVM with microprofile, JAX-RS, CDIs, microprofile config, and we are able, to execute everything in 6 milliseconds. So we could actually do the math right now and go AWS Lambda pricing, and pricing, and do the math. Pricing calculator. Get your estimate now. So what we would like to do. Architecture, Ohio, let's go to Frankfurt, is more expensive usually. EU, Frankfurt. Then change region. Per month. So let's go 2 million per month. Duration was 6 milliseconds. And we had 512 max. And so then we would pay for this 20 cents, which cannot be, but 2 million is not a lot. 2 per second is better. So €1 then. Okay. So Ivan asked me the entire JAX WS. I don't know whether Corkus supports JAX WS. If it does, it would work. But Ivan, I give you another hint. There is, it's called AWS Serverless Container, I think, Jersey. Not this. Yeah, this is from AWS, but I am searching for GitHub. So it is called Serverless Containers, and there is one implementation for Jersey, and this is the technology behind what happens right now. So what happens right now is the API gateway gets the HTTP event, passes it to Corkus. Corkus receives the event because the handler here, this is the handler, Corkus Stream Event Handler, it receives the HTTP event and calls JAX-RS. Corkus could call without any problems JAX-WS endpoint. So from technical perspective, very possible. Whether it is as easy as I showed you, no idea, because I didn't use SOAP for, I don't know, 10 years or 5 years. So yeah, Kasper, this is free tier. So you are right. What I will have to do is I will have to deactivate the free tier for the pricing calculator. So I will have to do this without the free tier. And then I would say per second. So I get 2 invocations per second. Durations, let's say 10 milliseconds. And 512 megs of RAM. This is what we specified. And you will see €1.50 still without the free tier. Yeah, and as I said, the same solution as the smallest EC2 server will cost you €30 at least. Nice. So, and what we could tweak here already, we could say max concurrency, let's say 1. There will max pool size 1. This is the built-in bulkhead, as is called reserved concurrency execution. And by the way, I could actually call the Lambda from outside. Could go here and say curl and call it. And this was hello. And I get back cold start, warm start, warm start, warm start, warm start. And let's see how slow or fast is it time. So this takes 0.128 milliseconds. So if we compare it with time curl HTTPS, let's say AHEX Live, this is my website, static, completely static. It is slower, interestingly. And the server is behind me almost. And this is Apache website. And let's go maybe Amazon.com. Also slower. So as already see, a warm Java function is incredibly fast. So the entire thing is executed in 6 milliseconds. And this is, I would say, already you could have, 10 endpoints, JAX-RS endpoints inside a Lambda. And it will execute faster than JavaScript or Python has to. So we can save money with Java. Any questions? If not, Gregor, we need your question. This should be, if someone will attend the next session with Venkat, this should be, the tradition of Devflix. If there are no questions from the audience, then Gregor will have to ask question. Greg, no questions?
Oh, sorry, I was on mute again. So I was talking that session with Venkat is Ask Me Anything. So there is no presentation, just pure questions and ask.
Oh, so then I don't see a lot of success with your audience in this Venkat session, There will be an hour of silence. Did you do some comparisons with Google App Engine or the equivalent to Azure? Azure Functions is the name, almost identical. You could ship exactly the same code to Azure Functions. The only difference is in Azure Functions there is a Maven plugin for Microsoft which packages this. There is no Corkus extension Maven plugin for Microsoft. Google Cloud Functions, very similar, and Oracle Functions also similar, but Amazon was the first, and everyone and they are a little bit better with the support like reserve concurrency, provision concurrency, and all the support. Okay. Then let's proceed with the slides. So what is the future of the cloud? And I would say what the future is this what management would like to see. This is not what we like to see, but our sponsors, management, and CTOs would like to see. And what they like to see is business traceability. And I already saw this in the cloud projects. So there were 10 microservices, and the monthly bill management saw that, and they came to me and asked, we are paying for 10 microservices. What if we merge all the microservices to one monolith? Is it going to be cheaper? And the truth is, in most cases, yes. So if you merge everything to one monolith, this is going to be cheaper. So what it means is we will have to justify us in future in public clouds, not by CPU consumption, decoupling, modularization, whatever, just by costs. So I call it cost-driven architecture or cost-driven development, CDD or CDA, because it already happens to me. So what is the future in the cloud, I would say? Requests are proportional to costs. If an application has a lot of traffic, it is more expensive, the application with less traffic. From business perspective, it makes absolute sense, right? If Gregor will sell, millions of tickets for the DevOps conference and the overhead per ticket is 10 cents, no problem for Greg. But if the conference, it will sell, 2 tickets for Devflix, and will have to run, the entire Kubernetes cluster, and they will pay €300 per month. This is a huge business problem, right? So I would say from the business perspective, makes absolute sense that every business transaction costs some amount of money. So this is unpredictable. So what it means is the best possible case is that the costs incur per transaction, request, or invocation. This is what I see is the future. And this future is called event-driven architecture or serverless. This is the serverless is this what we would like to have. And event-driven architecture is a consequence, because what you saw right now is the Lambdas behind the scenes were actually HTTP event listener. So all Lambdas are event-driven. And there was only a very specific case right now. There were synchronous Lambda, which were invoked from outside. Exactly what Casper says, it won't be cheaper because you will need to pay to the devs. Or Casper, what you probably mean is that what we shouldn't forget is that the developers or the development and maintenance costs are also there. I'm with you, but it is not like, back then I saw crazy architectures where 5 developers developed 100 microservices without a reason. And I asked them why you're doing this. Yeah, because they would like to have microservices. In the cloud, they will have to justify themselves why you do this. So I would say, and no kidding, what you can actually already do, I'm looking at my bill, what causes, was is German, what causes the highest costs, and what causes the costs is usually also consumes the most traffic, CPU or whatever. So you can profile your applications by dollars or zloty or euro. Zloty, there's no more zloty. Do you have actually zloty? No more, right? Euros, of course. Sorry. But zloty still. That's the question. I think at the first conference there was still zloty. I remember this because in one point of time I wanted to convert the zloty to euro, and my zloty was too old. When was the euro introduced in Poland?
Not yet. It was every couple of years we have a date for joining the euro.
Yeah, they still have zloty. Then the conversion was not in Poland, was in Czech Republic or somewhere. So they got the euros, And not Slovakia or somewhere. Yeah,
has still its own currency.
Exactly. Slovakia, exactly. This was where I had the whatever they had, and then I was not able to convert it to euros. Okay, so you have still zloty. Okay, perfect.
Yeah.
So it means a zloty-driven development. So you see, where the most zlotys are lost, and this will probably, consume the most CPU. And if your service is important for the business, it's absolute fine that it's expensive, because the business even, earns more than the costs actually. Very good. Now, serverless computing. I actually hate the term. It doesn't make any sense, because there are servers still. But what it means is actually that you don't have to care about the servers. So what you already saw, I just said, I need 512 RAMs. I didn't say, which machine, what machines. I don't care. I just shipped this, and this is the serverless Lambda. In the cloud, you get serverless databases like Aurora or DynamoDB. You get serverless queuing systems like Kinesis, for instance. Or what means serverless? If you start Postgres on Amazon, you will say RDS, and you have to wait 10 minutes, and you have your RDS, and you will pay, the entire time. Or you can say Aurora, and it can scale and down and up more quickly, still Postgres compatible, but you pay per invocation. What is cheaper? It really depends. Because under very high load, Lambda becomes more expensive than ECS Fargate, for instance, or EC2 machines, because, if you have to pay, this is call per, or you are charged per invocation, and the more calls you get, the more expensive it gets. But in Kubernetes or ECS Fargate, you get the fixed costs. Okay. And by the way, Kubernetes is the most expensive solution in public clouds, and I wouldn't use Kubernetes because it's too complicated. Everything else is easier. So on Azure Container Instances or Azure App Service is way easier than Kubernetes, and on AWS, I would use ECS Fargate or Lambda, for instance. Okay, and sorry with the zloty. I thought this is already euro, but because of Corona, I wasn't in Poland. I think the last time I was at the Devflix Krakow, it was 2019, I suspect. So, yeah. So, AWS Lambda is always event-driven, and there are synchronous and asynchronous Lambdas. Now, if you take a look at the Lambda, this is where I got the diagram from. So, the Lambda service, there's execution environment, which you could rename to EJB container, it would be the same principle. And there's a runtime function, and you always hit the execution environment first, and then the process wakes up. The difference is in the AWS Lambda world, Lambda starts the entire container with Java inside, and on application servers we only started the Java class. So this is a significant difference. Kasper asked me, Spring Boot. Yeah, I have no experience with Spring Boot. I'm not using Spring Boot in my projects. The reason being is because I use, Java EE and Microprofile in the past, and as Corkus came up, Corkus doesn't use any reflection, so it starts faster than application servers and Spring Boot. So with Spring Boot, it wouldn't be as fast as Corkus, and it will cost more, and therefore there is no Spring Boot in my world in the cloud, because it would start slower than Corkus or Micronaut, and therefore will incur more costs, and therefore we are not using it. And Spring Boot is complete different architecture. Spring Boot is very similar to application servers. It uses internally reflection a lot, like application servers are using, and reflection is great if you would like dynamically reconfigure your system. The problem is the startup time with the class loading and reflection. It takes longer than something like Corkus. What Corkus does at build time, it builds bytecode in advance and eliminates any reflection. It doesn't read any configuration, so that it optimizes for speed and memory size. And if you don't like Corkus, Micronaut is very similar. And by the way, I performed an interview with Graham Rocher from Micronaut. And Graham Rocher worked on Spring Data back then, and Spring Data was inspired by Grails, where Graham came from. Okay, Kasper. Very good. So yeah, it will take for too long. Yeah, this is true. Or what it makes too longer, and therefore will cost more. Okay, now from the lifecycle perspective, there was extension init, runtime init, function init. So there's the init phase, then the Lambda is invoked. Invoke is warm, and then it's destroyed. So this was like in EJBs, we had not exists, then it's pulled. This is the pulled state, and then destroyed. And this is new Lambda states. It will come this year, end of this year. Preview is available from June to this year, so you can try it. And what you get, the states. Now we get this, the function is created, that we get a pending state. The state is going to be active, inactive, or failed, which if you look at this, very, very similar to EJBs. And also what we get in Lambda, update status. So if you introduce a new version of a Lambda, this is, by the way, where Lambdas are ahead because there was no versioning, no working versioning for EJBs. But in Lambda there is. You can have aliases and versions in Lambdas. So what you can do in Lambda is, if you update Lambda to a new version, there are two new states, active and inactive, and this is during an update. And this was the last slide. If you like, 5 minutes, I could show you an example of an asynchronous Lambda without Corkus, because there is another use case, and then this will conclude. So if you have questions, feel free to ask, or see you on my upcoming workshops if you like, AirHacks Live, or if you have any questions left and you are shy, then go to AirHacks TV and you can ask per gist, and I will answer all the questions next time. So if you like, Gregor, if you have time, 5 minutes, I will show the asynchronous Lambda, which will, conclude the session. Is it okay for you, Greg?
Yes, sure. Go ahead.
Okay. So what about getting a database connection from the pool in a Lambda function? In a Lambda function, you would have one JDBC connection per Lambda. So you would do class for name and so forth. And on AWS, this is so-called RDS proxy, Relation Database Service Proxy, which will sit between the Lambda and the database to eliminate, the connection problems. Yeah, this is the solution. But it doesn't make any sense to have a connection pool in Lambdas. So the Lambda will just, pick one connection and keep it. So this is what Lambda will do. And it works well. But there would be one connection per Lambda. Of course, if you get 1,000 Lambdas, then the question is, can your database handle 1,000 concurrent connections? This is the problem. And there is, RDS proxy. This is the name of the thing, kicks in. Now, another thing which is useful, you saw this like Lambda which mimics Corkus or application servers. So there's a different project. It's called AWS Lambda CDK plane, and this is the more pure version of Lambda. And what this Lambda does is it listens to asynchronous events, and this is the idea of event-driven architecture. Push pull from SQS. You mean, Kasper, not push to SQS rather than pull from SQS, I would say. Lambda with CDK project, and now call it Devflix async. So, two other projects. I would like to close this one and open this one. So similar. So here. This is the stack, and this is my Lambda. This time with 128 megs of RAM. So keep it this way, because this is the smallest deployable Lambda you can get. So this time, as you take a look on this is Lambda handler. This is actually the POJO here. So if you take a look at the POJO here, this is main greetings. You see this is the on event here. And this matches with fully qualified name with on event here. And the name, let's call it AirHacks Devflix Devflix async or event-driven architecture. So, and the Lambda is exactly the same. Okay, so let's deploy this. So, and now it is going to be executed without API gateway, and it would listen to whatever I register the Lambda to, like SQS, SNS, S3, code commit, whatever, but I will test it with the Lambda tester. Yeah, Casper, pull. You could push, but okay, this is actually cool. Casper, you are great, because if you would like to push to SQS, there is a cool thing called Lambda destinations. And what this does, so this Lambda returns a string. I could configure a destination to an SQS queue, and what this does is the Lambda runtime will wait until Java returns, will pick the string and push it to the SQS queue automatically for you. You don't have to do this. Okay. Now let's see. I will go to the browser and go to the functions. This is Devflix. In a few seconds, we should see Devflix EDA. And by the way, it's a pity, because this ships, this entire Maven project ships with AWS CDK, SDK APIs, which is not necessary here. So I could actually comment out these APIs. So we would see a plain Java Pojo, and you will see how small this actually is. So now it will be roughly 1 meg, I think. So this is, usually it will be 5K. So, and this is like asynchronous Lambda. And you see there is no API gateway. And this is Hello World event. So if I call it, so this is the cold start. And if you take a look, it takes 700 milliseconds. This was the cold start. And you get billed by half a second. And now the subsequent call is 2 milliseconds. And the fastest call duration is 1 millisecond. There is 1 millisecond precise billing. So JavaScript and Python is going to be slower than Java. So which DI container do you recommend for Lambdas for performance? Either Micronaut or Corkus. Both are fast. For asynchronous Lambda, I don't recommend any containers, dependency injection. I recommend, I'm actually compatible with the Polish wizard. Gregor knows the guy. I actually, it was also my podcast. I forgot his name. It looks like a wizard. And he hates dependency injection. And he also attended Devox several times, Krakow. Gregor, you know the name of the guy? The Polish wizard. It looks like a monk. Actually,
yeah, Ratajski, Jarosław, Jarek.
Yeah, exactly. Yeah. So this is the guy, Jarek, yes. With lots of zeros. So why wizards hate dependency injection with aspect. So I also interviewed him, because the cool story is he was really nice, but he looks scary. So like a bird, and he was, for me, it looks like a monk, and he was always in my talks. But he was very friendly to me, and I say, what's the deal with you? Why you look so scary? It's like, I'm not looking scary, I'm looking like a wizard. And then we had a conversation, and he said, I'm actually hate dependency injection. And my answer was, I like dependency injection. And so we had a nice conversation. But in the asynchronous Lambda, I'm in the opinion of Jarek, you don't need dependency injection in asynchronous Lambdas, because you can just create with new, and I mean, this is not like, a big deal. But if you have a micro-profile application, then dependency injection makes sense, because you can port it to synchronous Lambda more easily. Exactly. This is the nice Polish wizard guy. Is he still active, Gregor, on your Devox?
Yes, he's presenting. He's living in Switzerland probably right now, but he's coming to Poland for a couple of conferences and he was at the last Devflix as well.
Yeah, nice. So greetings to him. So you have also invite him to Devflix. So he will hate all the dependency injections.
Yes, yes.
So what we saw now, the asynchronous Lambda, and we saw that it's actually even faster, as fast as can be, right? So, and if you put the more dependencies you add to the Lambdas, so this was actually fun. So recently someone added, I don't know, 3 different logging libraries to the Lambda, and it booted in 10 seconds. And this was like 10 megs of logging. I don't know why, because it's not necessary at all. If you would like to log, you can even use system out println. No one cares. Yeah. Okay, nice. I think then we covered everything. Or you can have, questions right now. Yeah. Any questions left? We can have freestyle conversation. If not, I'm done with my stuff, actually.
Definitely. Thank you very much. So guys, if you have any questions, you can join on stage as well with the mic and camera if you want.
Yeah, it would be nice
to talk to Adam.
What are the differences between AWS Lambda and Beanstalk? AWS Beanstalk is a complete different beast. With AWS Beanstalk, it will generate for you the entire environment with VPCs, subnets, and containers. So they are completely unrelated, I would say. Apache Beanstalk is similar to, I would say, to Fargate, but this is this is not that. It's different. And also the billing is completely different between Beanstalk and Lambda.
So Adam, if you are new for the as a cloud developer, what environment do you propose? AWS or Azure? If you are new,
what are you asking? What I would suggest you to start with?
Yes.
So AWS was the first, and they are the most mature. So the problem with Azure is there are lots of services still in preview. So for instance, you get on AWS managed Kafka, on an Azure is not available yet. Small things, right? But Azure and AWS are nice. What also nice is actually Oracle Cloud, because it's very cheap, surprisingly. So how long? I don't know, but right now it's very cheap, Oracle Cloud. And if you're interested in Kubernetes, then Google Cloud is the best choice. So I'm using AWS a lot because it's the oldest cloud. And what happened recently is that the cloud, most of the clouds have technologies like VPCs and direct connect or the private link. And what this means is, in the larger companies, they can extend the networking to the cloud without making the services in the cloud publicly visible. And this is where most of my clients are interested in such a thing. And this is why the interest explodes right now, because back then no one was interested to have services available in the internet. Most of the companies would like to have internal services. But I'm working on the most projects I have on AWS, and then the second is Azure. And from market penetration, the AWS is a leader. Oh, why I also like AWS? Azure is too young, but AWS is very much like Java. They never deprecated a service. This is remarkable. Even services from 2006 are still available, which is very compatible with my point of view. I mean, this is what we have in Java. So what kind of services do you recommend to implement on Lambdas? Ivan asked a great question. Like Kafka. So if you do Kafka right, then Kafka is like, the single source of truth. This is your database, and you are reacting to the business events. And this is the future, actually. Like the AWS Lambdas are reacting to events. To give you an example, So what is somehow common in enterprise companies, your application server scans a folder, and if a business department uploads a document, the document is read, parsed, and stored in a database, let's say, right? So you will have to implement the scanning. You would use Apache Camel for such a task, let's say. But this is a classic case for Lambda. This would work this way. You have S3 bucket. You could open the bucket so the business department can upload the document. This bucket will generate a S3 event. A Lambda wakes up, gets the data, processes the data, and stores the data with Lambda destination, let's say, to SQS, SNS, or Kinesis. Another Lambda wakes up, validates the document, parses the document, and stores the data to DynamoDB, which causes another event called, I think it's called DynamoDB streams. Another Lambda listens and sends the email to another user. This would be a classic event-driven architecture, which makes a lot of sense because it's easier. This is what we did with, polling folders or whatever. So think in this way, the cloud are generating already a lot of events, and you are subscribing to these events and creating a new events, which is very similar to Kafka architecture without Kafka, because you don't have to run Kafka to have it. And Kafka in the cloud, the cheapest Kafka, managed Kafka, I actually tested this today for our client. It will cost you roughly €40 a month, the cheapest Kafka installation. And a mid-range Kafka installation on a more beefy machines, 2 brokers, will cost you roughly €1,000 a month. So do you have some ideas how to protect unexpected costs like launch 100 EC2s besides standard solutions like budgets? On Lambda is the reserved concurrency. So what you saw is 2, so you will never manage to create more than 2. On EC2, if you're speaking about EC2, what you could do, the most obvious solution for EC2 is CloudWatch events. This auto-scaling in EC2 creates some CloudWatch events. You can react to these events with Lambda and just, shut down the machines. So you can roll back the auto-scaling. So this would be like an relative simple Lambda solution to this. In your particular case, the auto-scaling would be configured wrongly. So if you're just speaking about EC2, in Lambda is reserved concurrency, and on Fargate would be exactly the same, the amount of tasks. So every service, you can do this with every service. And if your Lambda is unprotected, so in Frankfurt, or if you have a starter account, you can start 1,000 Lambdas concurrently at the same time. And what do you have to be aware? You should never call your Lambda recursively, because then you can, spend a lot of money in a night. So this is a small tip. Don't call your Lambda recursively. Yeah, on what budgets are, so you can set up alarm and say, if something, creates more cost than €50 a month, then call me. Nice. Thank you a lot. And see you next time, right? And if there are interests, ping Gregor, and we can very, very quickly do something in this direction, whatever. So should be Java or web components related, whatever I do in my projects. I don't like to prepare to the session, so whatever I do is project related. Thank you, Adam. So there are 2 Adams at least today. And if you like, AX Live around the corner. And if you like this session, go to Greg, ping him, and we can do something next year.
Definitely.
This year won't vlog.
Still on mute. But yes, I will definitely try to reach out to you if there is interest, and there is, as I can see, and you can organize something again.
Sure. Whatever. So in this direction or something else, or we can hack something together, no problem. So
just questions. That would be better.
Yeah, this is for me very relaxing, because with this audience, no one asks questions, so I can hack, something here, and they will just watch.
And there was a couple of good questions and good comments.
Yeah, very, very good question. And you was the great, why we should do, why we're not keeping doing EJBs. Yeah.
Okay. Thank you, guys. Thank you, Adam, and see you in a couple weeks with Venkat.
Yeah,
if
with
you want
Venkat, he's
more
a
from
great
Adam,
guy. So
if you want
you have to
more-
ask questions, Venkat, because this is Ask Me Anything, what I learned. Without questions, the
Yes.
show won't be successful.
Yeah, I hope that people will come with their own questions. And if you want more from Adam, there's AirHacks Live, so the workshop that Adam is doing. So you can learn much more than during this 1 hour session like this one. So,
Yeah, and otherwise, DevOps online or whatever. Thank you.
Thank you very much, and bye-bye.
Bye.